We are going to spend the next 3 days talking about section 7.2. So 7.2 and 7.3 both involve volumes of some sort. So we're going to take this region, whatever region we're dealing with, and we're going to create some volumes. Okay. Just an FYI, you have your gold sheet, but your first quiz will come after we finish 7.2. So there'll be a quiz over 7.1 and 7.2. Then we'll do 7.3 and have a quiz and then our test, okay? So today and Tuesday, we're gonna talk about volumes of revolution. So we are going to take a region and we're gonna rotate it about an axis so it becomes a three-dimensional solid. Yes. Well, we're going to do the math of what the volume of this is. Okay. Now, there are two different ways that we can find the volume. We're going to learn the disc washer method today, and then the shell method in a week and a half. Disc washer. Yes. Okay, you do you. Okay. What, Quinn? You don't need to.
Okay. Great.
Was that your question?
Yeah. Sure. Yeah.
Are you like all texting each other and so you know what their conversation's about? Suggestion. Say that, Nathan. You whisper something under your breath. Yeah. Your voice, and you said it very deeply. All right, so right now I want you to just drop your pencil. Why, it didn't have one anyway. Okay. So what I want you to notice is that, how do I want to do this? Okay, so you can see this is our region. And I took like a little slice and I highlighted it here. So this looks like a disc. This looks like a washer. So right now we need to go through the math behind how do we find volumes of this, okay? So you're not gonna write this down yet. So here's a region. And I'm going to rotate it about the x-axis. Okay? Here's a look at inside, okay? So we are taking these rectangles, maybe, you remember these rectangles that I make you draw in here with thickness dx? Oh, you can't even see that. Okay, with thickness dx, we're gonna rotate them about. So we have infinitely many rectangles that we're rotating about. So here kind of is like a look inside. So because my curve kind of angles up like this, we have like this hole that gets bigger and bigger as we go out, right? So we have these infinitely many, infinitely thin discs, okay, where they have a hole in the middle. That's why we call it the washer method, okay? How do you find the volume of a disc? Pi r squared h. So right now I'm just talking about a disc. Okay. Pi r squared h. Now, and remember, you still don't have to write anything down right now. Okay, it's fine. How do you find the volume of a washer? Okay, so pi r squared h minus pi r squared h. So we take the big disk and we subtract the small disk, AKA the hole in the middle. Yes. Are you saying that I could factor out the pi h and we could take r squared minus r squared?
Yeah.
Interesting. Okay. So basically what's happening is the volume of our washer is pi times h times the radius squared of our outer circle minus radius squared of our inner circle, right? Okay. Now think about these washers, but now they're like perpendicular to the x-axis, right? That's what we're going to be doing today. Okay. And we don't just have one washer, do we? How many do we have? Many, and they're infinitely thin with thickness dx. Okay. So if we're talking about the volume of any given washer, remember our thickness is dx. So instead of h, I wrote delta x. Again, this isn't something that we need to write down quite yet. Okay. And if we look at this function here, or this region, this top function, if we call it f of x, and this bottom function, if we call it g of x, okay, f of x to the x-axis would be our big radius. G of x to the x-axis would be our small radius. So our functions are giving us how big those radii are. And we gotta sum these up. Do we have like a calculus thing that adds a bunch of things together? Mm-hmm. What's it called? It's called an integral. This is what you need to write down. I don't have favorites. Out of all my years teaching, you're not the worst. Did I spell outer right?
I know you put two T's.
Like this doesn't look right.
Only one. Maybe it needs
Just have some fun, Matthew. I need a new dishwasher. Okay, so again, our limits of integration are going to come from where our region starts and stops, so potentially intersection points, okay? Our outer radius is going to be the one furthest from the axis that we're rotating about, and our inner radius is going to be the closer one, okay? Maybe this one is like the top function and this one's, I don't know, the bottom function. We'll see. For now, if we're going around the x-axis, that's how it'll work. Once we go around a different line, we have to talk about something else. Okay. Okay. Are we ready for some examples? Okay, I think, don't quote me, we have 4 examples, but I might not be remembering correctly, so we'll just go with the flow. Okay, I think we have 4. It's gonna be okay. It becomes very, very important that you draw your picture with the rectangle. What? X minus 1. Am I thinking about this correct? Yeah, and then up 1.
Oh,
Okay. Okay. So it'd be that little guy right there, right? This little guy? Why? Me too.
It looks better than mine. You're supposed to know what area it is.
We don't care about the area. All right, so if I draw in my rectangle of thickness dx, I want you to imagine. So first of all, in addition to your picture with your rectangle, you need to indicate what you're rotating about. So we are rotating about the x-axis, which means I have that little circular arrow going around the x-axis, okay? I'm not gonna make you draw it, but I want you to imagine this rectangle popping out of your paper and rotating around the x-axis. Imagine it, please. Imagine it. What does it look like? Does it look like a donut?
Yes.
Okay, just this one rectangle, I want you to imagine it. Does it look like a donut?
Yeah.
Okay, a really flat donut, AKA a washer, okay? Now, if we take this whole picture, it's kind of like we have like a pointy, yeah, with like a really big, yeah, okay, okay.
It's like a circle and it's not like a bridge.
So like, yeah, this right here would create like a disc, but these are gonna create like a bundt cake kind of, but pointy. Okay, so we have pi r squared h. Okay, so there's our pi. H is our dx. But then we have radius squared minus radius squared. Okay. If we look at this rectangle, which part of the rectangle is furthest from the x-axis? The red one, right? Okay, this is our outer radius, And this would be our inner radius. Okay, so our outer radius is x minus 1 squared plus 1, and our inner radius is x. All right, we've got some complaints over here on the left side of the room. You're right. I don't want to do this. Sarcastically, he said, you're gonna use math 9.
Oh, yeah.
Yes. Oh, what are our limits of integration? 0 to 1. This is what I want you to do. Don't put in the pi. In your calculator, I want you to math 9 this, and then at the end, we'll multiply it by pi. Why is it 0 to 1? Okay. Because this starts at 0, x equals 0, and then this intersection point, this intersection point right here is 1. What? What could I help you?
Like when the area goes, we're doing dx and it goes up to 2.
But 2 would be the y value. Since we're doing dx, we need x. So horizontally, this begins at 0, stops at 1. Okay, you're in yesterday mode, aren't you? And this is why our rectangles are important. We have thickness dx. We can imagine that washer rotating around. And it also tells us, hey, since it's dx, horizontally is where I need to grab my limits of integration. Okay, did you get a fraction?
I can put it in the bracket. Nope.
2.16 repeating.
I
I got 1.
got 8.9. I put pi in though.
I don't want it with pi.
I got 1. But you multiply it by 5.
So you got 5, 6.
I got 4.8171.
So 5 pi over.
Yeah, 23 over 15. That's what I got.
So without pi, you got what?
23 over 15.
Then we multiply it by pi.
Yeah.
And now it's irrational, so don't try to make it a fraction after that. I want the rational number times pi. You can't multiply by pi and make it go to, okay. So this guy right here. Now. Make it correct. You can't put it in.
So
Okay. Are we okay?
it'd still be the same answer though.
But she wants a nice number and not 4.8176.
If it can be a fraction, I want a fraction pi. Okay. Okay. Glad we're on the same page. Next example. It's a nice one. Ah, shoot, what's the problem?
Where the tip of the umbrella is, that's gonna be like the edge.
Yeah. Wait,
Okay, so here's our solid that we are going to rotate around the x-axis. So let's imagine it. It's gonna kind of look like, I was thinking like a non-hollowed out like cup or vase, right? Where it's just like, but a solid. Like they're, yeah.
Those math, like those wooden block things that used to play with in, like sixth grade.
Yeah, okay, so it's like a cylinder, but with like a curve. Not a straight cylinder, like a curve, okay? Now, what I want you to do is I want you to imagine this rectangle with thickness dx rotating about. What is it going to create? A disc. There's no hole, right? Fine, that's fine. Okay, that's fine. Disc washer. Okay, so we have pi times the integral of r squared minus r squared h, and h is our dx, okay? Our limits of integration, what would they be? 1 to 4, easy. All right. Now, our outer radius is going to be the square root of x. What's our inner radius? Okay, you're welcome to write 0, or you're welcome to not write 0. I don't really care. Just to get through class quicker, go ahead and do this. Only put this into math 9, and then we'll tack on the pi. Let's make sure you're right. Matthew has gone ahead and found 15 halves. The rest of you need to confirm his 15 halves.
I don't. I mean, it's the same for everyone.
You got 15 halves.
Yeah. Oh, I just put it back to one. Kylie.
Yeah. All right. This is a very important example. What's different? It's not about the x-axis anymore. This changes everything. Nathan and Caitlin, what are you doing? It's kind of an annoying one.
Could be 6. Is this really
I got it.
Dylan's right. Okay, does this mean that we're ready to set this up? Okay, so we have pi integral from 0 to 1 of radius squared minus radius squared h, where h is our dx. Okay, 0 to 1, are we okay with those limits of integration? Okay, now I want you to imagine that rectangle rotating about y equals 2. We have washers with really giant holes in the middle, right? Okay, so we basically have like kind of like a donut that like has like this slant taken out.
It's like a walk. It's like a walk, but there's a hole in it.
Oh, yeah, I like that. I don't know what that is.
That's pretty beautiful.
It's an aerobie. Okay, cool. Now, our outer radius, which part of the rectangle is furthest away from our axis of rotation? This is our outer radius because the bottom of our rectangle is furthest away. So we have 2 minus x squared as our outer radius. That's the distance, top minus bottom. 2 minus parabola. Okay, then the top of our rectangle is closest to our axis of rotation, and that distance we would describe as 2 minus x. Top minus bottom, 2 minus x. But you have to determine which one is furthest away before you do top minus bottom. Which one is closest? Top minus bottom. Okay. What did you get? 8/15. So 8/15, and then we multiply by pi. You didn't get it, or you,
No, that's what I wrote down.
because it's what you got?
Yeah.
Or it's because it's what Isaac got?
No, it's what I got exactly. What I said. You wanted a
Good work.
cookie? I do actually.
Okay, we have 4 minutes to get through our last example, so I'm gonna go ahead and push to that, okay? Nathan, are you okay with this? Okay, Caitlin, you good? Okay, I saw you writing, so I wanted to make sure we were good. Okay, I want to take the same solid, but now we're gonna rotate about a different line. And what is significant about the line that I chose? You can't see it? Oh, it's below. It's not the same thing. Somebody who's being distracting. Okay, so we're still going to set up pi r squared minus r squared h. This time, for our outer radius, which part of the rectangle is furthest from what we're rotating about? Okay, this is our outer radius. And if I want this distance right here, top minus bottom, x minus -1. The bottom of our rectangle is the closest to our axis of rotation. So this is our inner radius, top minus bottom. We have x squared minus -1. The biggest battle is getting these set up. I know you can integrate and I know you can work your calculator, okay? The most important thing is getting these set up. Drawing a picture is the most important piece in getting these set up. You don't have a good picture, it's not gonna work out for you. Please pay attention on your gold sheet to which ones you should do by hand and which ones you should use a calculator for. If you cannot get something changed to a fraction, like you have a decimal that stays as a decimal, multiply it by pi and give me a decimal. Don't you dare give me some answer like 5.379 pi. No, just give me a decimal with pi already multiplied through, okay? Are you with me? Pet peeve.